lower bound. The upper bound is 0.911, 0.911. The midpoint is p hat, point estimate. And if I want to find the p hat is always equal to lower bound plus upper bound divided by 2. So I put my calculator and find the upper bound plus lower bound divided by 2. All right, so I have 0.6669 plus 0.911. If I hit enter, then I divide by 2. Then I find the sample proportion or the point estimate. So the point estimate in this question, p hat, is equal to 0.7. So according to my calculator, the point estimate is 0.790. 0.790. You know, it cannot be up to 1 because it's probability. This number cannot be up to 1. It's a probability. Okay, so p hat is always equal to x over n. So I am given the 0.790 is equal to x over n. So I might not actually know what x is now, but at the end of the day, I will know it. So I am just going to go back. So what are they asking me to find? Determine the point estimate of, so I did, of the population proportion. The margin of error is the distance between the upper bound and the point estimate. And the number of individuals in the sample with specified characteristics x. Okay, so they want me to find x. So if I already know n, so if I already, yes, I know n, they give me 1200. So n is 1200. I will just solve the proportion. If I solve the proportion, I see that x is equal to 1200 multiplied by 780, 0.780, actually 0.790. So the number of people who showed up is 1200 times 0.780. So the number of people who showed up is 1200 minus 0.780. So I have 1200 multiplied by 0.780, and I hit enter. And so actually, it is 936. So 936 people showed up. 936 showed up. So x is equal to 936 out of 1200. Okay, and then they want me to find the margin of error. How do I find the margin of error? The margin of error is the distance between the point estimate. See, point estimate is 0.790. So that's 0.790. All right. So what is the margin of error? The margin of error is this distance. So all I do is margin of error, and I can put it plus or minus because P is the midpoint of the line. So it is 0.911 minus 0.790. 790. And 790 is the point estimate, this distance. So I'm looking for this distance. 0.111 minus 0.790 is the margin of error. All right, so I am going to calculate the margin of error. So I have 0.911 minus 0.780 and what I have is 121. So the margin of error is equal to plus or minus 121. And by the way, it is in decimal 0.121. So that is the margin of error. And by the way, what do I mean by margin of error? If I add 0.790 plus 0.121, I get the upper bound. If I subtract 0.121 from 790, I'll get the lower bound. So now at this point, we can actually calculate the confidence interval. So let's calculate the confidence interval for P. Remember the conditions. These conditions must be satisfied. Conditions for converting from binomial to normal. Conditions for converting from binomial to normal distribution to normal. The first condition is that the variance must be greater than or equal to 10. So you will be told to find it anyway. So the variance, or you see, the variance of that must be greater than. So the variance must be greater than or equal to 10. So what is the variance? Variance is n times p times q. Must be greater than or equal to 10. That is one. The other condition number one, condition number two, is that the sample must be less than or equal to 5% of population. And what is population? Capital N. Sample must be less than or equal to 5% of population. And by the way, what is the population here? Population is 1,200. 1,200 is definitely less than 360 million. We know that. We can find it out. Therefore, condition number two is satisfied. We can check for condition number one. It is satisfied, but let's do that. So condition number one is sample size 1,200 multiplied by probability of success, and probability of success is given to us. We calculated it, and that's probability of success is 790.790 and probability of failure is 1 minus 0.790. And then we get our calculator and see, is this quantity greater than or equal to 10? Let's see. Let's check it out. So I will do the multiplication. And what I'm checking is that 1,200 multiplied by 0.790 multiplied by parentheses 1 minus 0.790. Close parentheses and hit enter. My answer is greater than 10. So condition number one is satisfied. So I can do inference. What do I mean by inference? I can do confidence interval. I can do hypothesis testing. If the condition is satisfied, I can do confidence interval or hypothesis testing. All right, so now I can find a question on confidence interval. Let's see. Question number 7 is confidence interval. construct a confidence interval of a population proportion at the given level of confidence. So I am given the confidence interval. The confidence interval is, let me pull up, and then I'm going to minimize it. And then I'm going to grab this and move it up. Okay, so the question here is find, I'm given the number of people who showed up, and sample size is given to me as 150. And I am told to find the confidence, I'm given the confidence interval of 0.95 or 95%. So we are going to do it using a calculator. So I can show you how to use calculator to quickly calculate confidence interval without wasting time. So I am going to go to calculator quickly and find the confidence interval for P. So I am going to start, arrow to test, and I am doing P confidence interval. The P confidence interval is called one proportion Z interval, one proportion Z interval. So that is it here. One prop Z interval is A. I select that. What is the number of people who showed up? 105. The sample size is 150. And the confidence level is given to me as 0.95. So I'm going to calculate. So the lower bound is 0.627, a number line. The lower bound of this confidence interval and the upper bound is here, and the middle is the sample proportion, P hat. Okay, so I'm going to pull my calculator up again. The upper bound is 0.773, 0.773. The lower bound is 0.627. And then P hat is given to me as 0.700 or 0.7. And then I already can find the margin of error. The margin of error is the distance from the upper bound and the P hat. If I do upper bound minus P hat, I have 0.073. And this is 0.073 also. Therefore, the margin of error is 0.073. All right, so now let's see if they have any other question. We did confidence interval. We can do it quickly. It doesn't take time. We can do it quickly. It doesn't really take time. So we did number 7. We found the confidence interval. The lower bound is 0.627. The upper bound is 0.773. The margin of error, even though they didn't ask us about margin of error. The margin of error is the distance between the point estimates, sample proportion, and lower bound. And I can say that I can actually say that I am 95% confident that the point estimate is 0.7 plus or minus the margin of error, plus or minus the margin of error. And so that margin of error is 0.073. Okay? And this is a way to calculate. And you can actually be told to use formula. The formula is, we already told you, the formula is population proportion is sample proportion plus or minus the critical value provided the conditions are satisfied. The critical value Z alpha over 2 multiplied by square root of P hat, Q hat over n. So this is the formula, but if you're told to use the formula, you can use the formula. Otherwise, you can just go straight and put it in your calculator. So let's do another example. So we're going to do one more example. Let's go to number 8. Let's do number 8. Construct a confidence interval of the population proportion at the given level of confidence. So right here in this question, I am given, right here in this question, I am given all right, so in number 8, what am I given? In number 8, I am given the X is equal to number who showed up, number of successes. The sample size is 150. The confidence interval is 99% or 0.99. So I'm told to calculate the confidence interval, right? The lower bound and upper bound. So it's easy. We do what we just did before. It's really easy. So pull your calculator up, go to Math, go to Stat, arrow to Test, and you're looking for one prop Z interval, one prop Z interval, and that is A. So one prop Z interval is what you're looking for. And X is 105. The sample size is 150. The confidence interval is 0.99. And then I calculate and lower bound, very easy. So this time I'm going to find the upper bound and lower bound. So I'm going to find the upper bound is 0.796. Lower bound is 0.604. The point estimate is given to me as 0.7 again. And the sample size is 150. All right. So if I'm told to find the margin of error, I would just, the margin of error to the right is the same as 0.096. 0.096. So that is the margin of error. And then now that I found the margin of error, I can conclude that at 99% confidence interval, okay, then the margin of error, I can say that population proportion is equal to sample proportion plus or minus the margin of error, which is 0.076. 0.076. At 99, remember you have to be confident to the percentage of confidence given to you. So I am given 99% confidence. So at 99% confidence, the population proportion is point estimate, sample proportion, plus or minus the margin of error. Plus or minus the margin of error. Okay, so we have talked about calculation of confidence interval using sample proportion and population parameters, provided the conditions for converting from binomial to normal is satisfied. And we already know the conditions. The conditions which they'll ask you all the time, condition number 1, the variance of the sample NPQ must be greater than or equal to 10. So the variance NPQ must be greater than or equal to 10. And condition number 2, the sample size must be less than or equal to 5% of population. And this will go because what is the population? We're talking about the whole Americans. And so the population given to us in this question, let's see what that population is, by the way. So we are going to see the population in number 8. See, I think it's same population. By the way, we are given sample size of 150. That's an insignificant sample. Therefore, the conditions are satisfied, we can do inference. Conditions are satisfied, we can do inference. I think we can do one more question. We can do one more question. Number 9, constructs a confidence interval. Let me see, what are we doing? Unit 4 practice test. Okay. So number 9, one last example for this. In number 9, construct a confidence interval for proportion. What you like is write the equation. So write the equation. I'm going to write the equation. If you want to write the equation, that's fine. Sometimes you are asked to write the equation, but if you're not asked to write the equation, then you go ahead. So the estimate of the population proportion is equal to sample proportion plus or minus the critical value, two-tailed critical value, multiplied by standard error. So standard error for proportion is that divided by sample size. But really, I don't have to use the formula. I can use my calculator. So the first thing I want to do is to draw a number line so that I can show that this is lower bound of the number line. This is the upper bound of the number line. The midpoint of the number line is the p hat, the sample proportion. So I can go to test and 1 prob z interval. But what are the numbers that I'm given in that question? So let me get those numbers. The numbers that I'm given is that in number 9, I'm given that x is 860. So x is 860. So I'm going to, so x equal to 860. Sample size is 1200. And confidence interval is 0.1, 0.9, 90%. All right, if confidence interval is 90% and everything is given to me, I'll quickly go to my calculator and use my calculator to find the confidence interval for proportion. So all this time we have been doing proportion today. Confidence interval for proportion, that's what we have been doing. All right, so I will go to my calculator and go to start, arrow to test, and arrow down to look for 1 prob z interval. So what do I find? Yes, 1 prob z interval. I know that it takes time, but you can find it. What is the x given to me? The x given to me in this question is 86. So I'll put in 86 there. What is the sample size given to me? The sample size given to me in this question is 1200. 1200. And what is the confidence interval given to me is 0.9. And then I'm going to calculate. So it actually has given me the lower bound and upper bound of the confidence interval. The lower bound is 0.059. So the lower bound is 0.059, 0.059. And the upper bound is 0.084. And if I'm told to find the margin of error, well, anyway, let me first of all write the point estimate. The point estimate is 0.72. If I'm told to find the margin of error, this is margin of error, the distance from point estimate to upper bound. So all I have to do is 0.84 minus 0.72. So I'm just going to go back. All right. And that's 0.072 though. So I'm just going to do is 0.072. Okay, so I will get my calculator and find the distance. What is the distance between upper bound and lower bound? So the distance between upper bound and lower bound is 0.084, 0.084 minus the point estimate, 0.072, and that's the margin of error. So the margin of error is 0.012. So margin of error is 0.012, 0.012. If I find the margin of error here, I have 0.012 also. And by the way, what is this margin of error? The margin of error is this quantity. Margin of error is this quantity. So, and that margin of error is 0.012. Therefore, the estimate of the population proportion, is sample proportion. So remember that population proportion is P, capital P. So capital P, population proportion, is equal to sample proportion plus or minus margin of error. And by the way, I don't really have to, unless I'm told to write it this way. Otherwise, I go straight to the question. So the estimate of the population proportion to the sample proportion I found, 0.072 plus or minus the margin of error I calculated. So I can now say, therefore, I am 90% confident. Therefore, I am 90% confident that the population proportion lies between the lower bound, 0.072 minus 0.012 to 0.072 plus the margin of error. Therefore, you cannot be more confident than the confidence level given to you. You cannot be more confident than the confidence level given to you. So this time I'm given 90% confidence. I have to say, I am 90% confident. I am 90% confident. Okay, tomorrow, next time we're going to review proportion confidence interval before we get into confidence interval for the means. So today we did proportion confidence interval. We used